Hello, digital wizards, code conjurers, and Python prestidigitators. Welcome to the whimsical world of object-oriented programming, or OOP as we call it, when we're too lazy to use full names. Today we dive headfirst, with a helmet on, of course, into the mystical realm of classes and objects. Imagine you're in a magical kitchen where, instead of pots and pans, you have classes and objects to cook up some delicious code stew. Picture a class as a spellbook. It contains the spells, methods, and ingredients, attributes, needed to create magical entities, objects. A class doesn't do much on its own, but it holds the potential for great power. Let's conjure our first class. We shall create a spellbook for a wizard. This spellbook will hold the secrets, attributes, and spells, methods, of our wizard. Behold the spellbook class. The __init___ method is our constructor, setting up the spellbook with its owner's name and a list of spells. The display_spells method allows us to reveal the spells within. The __init___ method is like the first spell in our book, invoked when a new spellbook is created. It sets the stage, initializing our object with all it needs to function in the magical world. Now let's bring our spellbook to life. Creating an instance of a class is like summoning a creature from a summoning circle. From our blueprint, a tangible, usable entity emerges. With a flick of our wand, or a press of a key, we summon Merlin_spellbook, an instance of our spellbook class, personalized for Merlin with his unique spells. Using Merlin_spellbook, display_spells, we can see all the magical spells at Merlin's disposal. In the realm of Python, a method is akin to a spell. It's a function that belongs to a class. Methods define the behaviors or actions that an object created from the class can perform. It's what makes our objects not just static entities, but active participants in our coding adventure. Let's craft a method in our spellbook class. We shall create a spell that allows a wizard to add new spells to their repertoire. Behold, the add_spell method. This enchantment allows our wizard to expand their magical arsenal. When invoked, it adds a new spell to the spellbook and announces its addition. Now let's see our method in action. We will summon Merlin's spellbook once again and add a spell to it. With a flourish of our coding wand, we add time travel to Merlin's collection, using Merlin_spellbook. Display_spells. We can now see all the powerful spells, including the newly added one, at Merlin's command. Imagine a class as a scroll containing the secrets of a magical creature. Creating an object is like chanting an incantation from this scroll, manifesting the creature in our realm. It's the moment when the abstract becomes tangible in the world of Python. Let's return to our spellbook class. With a few words of power, we will summon an instance of this class, a specific spellbook belonging to a wizard with its unique set of spells. Behold! We have conjured Gandalf's_spellbook, a unique instance of the spellbook class, equipped with Gandalf's personal collection of spells. It's no longer just a blueprint. It's a wizard's tool brimming with magic. With our spellbook now in physical form, let's see how we can interact with it. We can access its spells, add new ones, or even display its entire contents, all through the powers we defined in the class. As Gandalf adds invisibility to his spellbook, we witness the dynamic nature of objects. They're not just static scrolls. They're living entities in our code, capable of change and interaction. Class attributes are properties shared by all instances of a class, like a common enchantment cast upon every member of a wizarding guild. They are defined within the class but outside of any methods. In our wizard class, guild is a class attribute, common to all wizards. It's the banner under which all members of Magicians of the Mystic Order unite. Instance attributes, on the other hand, are unique to each object created from the class, like a wizard's personal spellbook. These attributes are typically defined within the __init___ method and vary from one instance to another. Here, Gandalf and Saruman are instances of the wizard class, each with their own name attribute. Though they share the same guild, their names, their instance attributes, are distinctly theirs. Class attributes come in handy when a property needs to be shared across all instances. Changing this attribute affects all instances that access it. By altering Wizard Guild, we've rebranded our entire guild. Gandalf and Saruman, along with all other members, now belong to the sorcerers of the Eternal Flame. In the enchanted land of Python, self is a parameter in methods that allows us to access the attributes and other methods within the class. It's how a wizard or object knows to refer to its own spells and possessions. Let's cast some code spells to see self in action. We'll enhance our wizard class with a method that allows a wizard to introduce themselves. In our introduce method, self acts as a gateway to the wizard's own name and type of magic. It's like the wizard saying, "In this mirror, I see myself, and so I speak my own name and my magical specialty." Let's bring our wizard class to life by creating an instance and invoking its introduce method. As Merlin casts introduce, he uses self to refer to his own attributes. The method pulls Merlin's name and magic type from within him, presenting them to the world. The self keyword is essential because it differentiates between internal attributes and external variables. It helps Python understand that we're talking about the wizard's own attributes, not something else named name or magic underscore type. Encapsulation in Python is like a magical barrier that protects the castle's treasures. It involves bundling data, attributes, and methods that act on the data into a single unit or class, and restricting direct access to some of the class's components. This is the essence of keeping the inner workings of an object hidden from the outside. Let's demonstrate encapsulation by creating a wizard class, where the wizard's magical energy or mana is kept hidden from direct access. In our wizard class, __ mana is a private attribute, indicated by the double underscores. It's hidden away like a secret chamber within the castle, accessible only through the methods we provide, such as use _ spell. Abstraction, on the other hand, is like the castle's facade, showing only what is necessary. It's about focusing on the essential qualities of something rather than the specific details. In OOP, it means creating simple interfaces for complex operations. Let's apply abstraction by adding a method to our wizard class that allows interaction without revealing the complexity of the wizard's spellcasting process. Here, cast _ spell provides a simple interface for the complex process of spellcasting, hiding the details of mana management. The user of the class or guest of the castle need not know about the inner workings of mana usage, and thus concludes our first foray into the enchanted land of classes and objects. We have learned to craft blueprints and breathe life into them, creating objects that hold the power of our code. In our next episode, we will venture further into the depths of OOP, exploring inheritance and polymorphism, where objects inherit traits and take on new forms.